Hey everyone, welcome back. So today we're going to be solving subtree of another tree problem. The prerequisite for this problem is another problem called as same tree, Leetcode. It is Leetcode 100. I would suggest you to solve this problem before you get to this because it is a part of this problem. Okay, so let's get started. So the question is very simple. You're given a root tree and then you're given a subtree. So what you have to do is you have to tell if this particular subtree is the is the part of this particular root tree. Okay, it's part of this root tree. Okay, now if you ask me, if I give you this, let's say that I tell you that there's another variable 7, another node. Okay, now I'm asking you if this particular tree is a subtree of this tree. What is the answer? No, right? Because even the descendants, right, even the child nodes for the subtree has to be the same as a root, right? So this is not the same tree as this when you have a node 7. Okay, and that is also mentioned in the question. If you see the question over here, you're having 3 4 1 2 5 0. Okay, and the subroot is given as 4 1 2. Though this tree is present, this particular 412 is present over here, this is not a valid answer because you have another node which is a child of 2 which is not present in the subroot, right? So we'll be returning false. Okay, so these are your conditions, these are your edge cases that we need to handle. Okay, now how do I know that if it's a subtree or not? We will see. But the conditions that I need to know are one is where the one that we just saw. If the root has any extra nodes that the subroot does not have, in that case I can just say that it is not a subtree, right? Okay, but let's consider this scenario. Okay, you see this subtree is part of this root, right? Because 4 1 2, it's the same structure as the root, right? And there is no extra nodes attached to the root, so I can say that this is subtree is a part of the uh, original tree. Okay, what if another case I have another root over here? Will this be part of this tree? No, obviously not, right? Because this particular structure is not over here, right? So I cannot say that. Okay, those two are the conditions that are given to you in the problem, and you'll have to consider those conditions. Okay, now let's think about it. Okay, what can be my edge cases, right? What can be the cases for which I can either return true or false, right? Because ideally the problem is asking you to return a boolean value, right? So I'll have to return either true or false, right? What can be my case? If my subtree, let's forget this particular tree, let's just say that the subtree is null, right? It's just null. There's no nodes at all, it's just null. Can I say that this subtree is a part of this root? I can say that, right? A null tree can be part of this root because at a leaf node you would get null, right? So you can, I mean, though this is not correct, you can ideally say that this null is a subtree of this. I can say that, right? So the first condition is, if my the first condition is that if my subtree, that is, let's consider it as let me consider root as s and subtree as t. Okay, a root tree as s and this subtree as t. Okay, if my t equals to null, I can say that it is a subtree, which means that I can return true, right? Now what is my second case? This is my first case. Let's consider the opposite scenario where my root is null. If my root is null and I have a value in subtree, can I say that, if my root is null and I have some value in the subtree, can I say that my subtree is a part of root? No, right? If root is null itself, you cannot say that, right? So you'll have to return false. So what I'm going to say is, if my root, that is s equals to null, what I'm going to say is return false. Perfect. I've handled these two conditions. Okay, now these two conditions are gone. Now there's a condition where both of them are not null. Okay, that is what the conditions. for these are, and those are the conditions that we're trying to handle, right? Now let's come back. Let us take a root. Okay, let's consider the starting root itself, 3 on the root, that is 3 on S, and then 4 on subroot. Okay, visually if you see, is this a subtree? No, it's not, right? Because your node values are different. Okay, so let's just consider this particular root 3, this particular node. Okay, what will happen in the backend? What will happen in the background, right? Ideally, what you would do, the first thing that you would check is, okay, these are two different problems. Okay, one problem is where you're passing the tree to another function. Right, you're passing either this subtree, or you're passing this subtree, or you're passing this subtree, or you're passing this subtree. You're passing these subtrees to another function, which will tell you if this particular subtree, or if this particular subtree is the same as this subtree, right? So one function is where you're passing the subtree, another function is accepting that subtree, and it's telling you, okay, is this subtree the same as this subtree? Okay, so we're gonna have two functions. One function is passing the subtree, another function is checking if those two subtrees are the same. Okay, so let us say that the first function is gonna pass this subtree, this entire subtree, as this. Okay, how are we gonna check? Okay, what we'll do is, we will say that okay, what we'll do is, okay, this is our function one scenarios, function one cases, right? Now coming to function 2. Now can I say that first thing, what is the first thing? Forget this particular thing. Let's consider a scenario where both of them are null. So this is the second function that I'm talking about. Please don't get confused. This is the second function. What is the second function doing? It's checking if same tree or not. All it's doing is it's checking if same tree or not. Okay, so tell me something. Let's just say that I pass two null nodes to that same tree. Okay, what is supposed to okay, wait, the return type of this is supposed to be boolean. Okay, if I pass two null nodes to a this function to check if it's the same tree or not, both of them are null, what should be the return value? It should be true, right? Because both these trees are null, I can say that these two trees are the same. Okay, so when true trees are same, that is when let's just consider it as P and R. Okay, if P equals to null, okay, and R equals to null, I can say that it is a subtree. I can return true. I can just return true. This would mean true. Okay, the first case. Okay, now what is the second case? The second case is, let's just say that P is null, but Q is not null. Q has a value. I'm passing these two trees. Okay, ideally even one node is a tree, right? I'm passing these two trees. Now can I say that these two trees are the same? No, I cannot, right? These two trees are different. So if either of them is null, if P is null, then also I'll return false, because that's not the same tree. Another scenario where this is 4 and this is n, this also I'll return false. Q is null, I'll return false. Perfect. Okay, now what is the other case? Let's say that both of them are not null. Okay, P is 4, Q is 5. Is this the same tree? No, it's not. Though the values are not null, though the node is not null, the values of it are different. So I can say if P dot val is not equal to Q dot val, I can just return false. Perfect. These two are my conditions. Okay, now let's consider this tree. That is, let's consider this tree of 3 4 1 and 2. Okay, now what will I do? I will pass this to my same tree function. This is my two trees that I need to check if it's the same tree or not. Okay, so ideally what will happen, it will, my pointer will be over here, not my pointer, my node will be over here. Okay, we'll check if these two are these two, it'll check these two nodes. Which condition does it fall under? It falls under this condition. So ideally what will happen in your stack, if you consider your stack, ideally what will happen, same tree function would be called, with uh, with two params. One is the first tree, second one is the other tree, PNR, right? Now if we consider this PNR, let me write this properly. Yeah, if we consider this PNR, are these PNR same? So what will happen, it'll come here, this condition is false, this condition it won't go through, this condition it won't go through, but this condition also it won't go through, but this condition will go through, right? So it will return false. So what will happen, this will return false, right? It'll return false, it'll directly return false. So I will come out. Perfect. Now I've come out. So I found out that, okay, this particular subtree is not the same as this subtree. Okay, now can I just return false saying that, okay, both the subtrees are not same? No, I cannot do that, right? Because a subtree of this tree can be equal to this tree, right? For example, this tree is a subtree of root, or S is the same as this subtree, which is nothing but T, right? So I still have to check the subtree of S, right? Yeah, I still have to check the subtree of S, right? So now let me so now I have to pass this particular subtree and this subtree into my second function, which will check if it's the same tree or not, right? So ideally what will I do? I'll go towards the left. I'll say that, okay, tell me if this particular subtree, that is 412, is the same as this particular subtree. Okay, now what will I do? I will check if 412 is the same as 412. Okay, let us stack trace over here. Okay, we will be calling same tree of Q and R. That is, let me consider the this thing as okay, that I can't do that, right? Okay, for just the case of easy understanding, this is not how it's going to be, because of course the address value is going to be different. Let me consider this as the same thing. Okay, obviously this will be different. This just for the visualization purpose. So please don't assume that the address is going to be the same as a value. It's not going to be the same. Okay, so what I'm saying is 4k 4 and 4, right? So now what's going to happen? It's going to check if these two values are same. These two values are not null. I'm checking if these two values are same. Yes, these two values are same. Now what am I supposed to do? Can I go towards the left for both of them? Yes, I'll go towards the left. So what will I do? I'll call same tree of 1k comma 1k, right? I'll call same tree of 1k comma 1k. Now it has gone to the left. Now I'll check these two values. Are these two values the same? Yes, these two values are the same. So now what will happen? It'll call same tree of so it'll call same tree, right? So it'll go towards the left. Now it'll go further towards the left, right? Yeah, it'll call null and null. Since both of them are null, your base condition is hit. That is nothing but this condition. So what will happen? This will return true. And another, since this returned true, this is also true. This will also return true. Perfect. This will also return true. Now I've checked the left. I've come back to my node. Okay, I have to go towards the right. Correct. So now what will I do? I'll go towards the right. I'll say same tree of 2 comma 2, right? For just for explaining it, let me consider this to be 9 and this to be 2. This will be 9k. Okay, so now obviously this is the same tree, but I'm just giving you a failure scenario, right? This is 9, this is 2. So what will happen? This will get evicted stack, out. This will come, 4 is there. So now I need to call left and right? Left is already called. So left will have a value true, and then right. Now right, I'll come to 9. So same tree of 9 comma 9 2 is called. Okay, so I'll check, is this the same tree? No, It's not the same tree, right? It's not the same tree because 9 and 2 are not the same. So what will this return? This will return me back false, right? So my left value is true, whereas my right value is false. Right value is true, right value is false. What can I return in this case? Can I say that if my left value is true and my right value is false, I'll have to return false because it's not the same tree. Only when both the values are the same, I can only then return true. Right, it makes sense because on the left side I found it to be false, which means that it's not the same tree. So I will return false. In this case, I'll return false. And how do we handle that condition? We will see that in the code, but yeah, in this case, I'll return false. Okay. Now, let's say that this found out that this tree is the same as this tree. I just explained you this example just to make you understand how it's returning true and false. But ideally, if you see over here, it is the same tree, right? So now I found out this to be the same tree. If I found out this to be the same tree, can I say that, okay, these two are the same trees, I need to return true. I'll return true. Can I say that? Okay, perfect, perfect. Now we got it, right? Now let's just say that this particular tree had another value like 6. Okay, in this case, what will happen? Okay, I will call this subtree, okay, and then I will send this subtree. Is this going to return true? No, it's going to return false. This thing is going to return false, right? If it returns false, what will I do? Okay, I return false. Maybe it's not the same tree. Then what will I do? I'll go towards the left. I'll go more towards the left. Then I'll take this entire subtree and I'll check with this. Again, a false. Then I'll go towards the right. I'll take this subtree and I'll check. Okay, false. I'll go to this tree. I'll check with this tree. Okay, false. I'll check with this tree. I'll check with this tree. False. Okay. Now this will return false. Okay. But let's consider this scenario itself. You know, where there is a subtree which is equal to the subroot. Right. Now will my computation stop? No, right? Because I've calculated only the left value. So I've calculated this tree. Okay. Let me write it better. I've calculated this tree. Okay, good. Now what will happen? It will still go towards the left. It will still go to 1. It'll check. It return false. Okay. Now it will go to the right. This will return true. Okay. Sorry. This will also return false. Then it'll go towards the right. It'll also return false. Now. Sorry. My bad. The thing is, I found out that this tree is equal to this tree, right? I found out that. Now, will it still go towards the left? No, because when I called root.left, this particular function has been returned with true. Next, what will happen? It'll call root.right, right? Obviously, it'll call root.right. What is that root.right? It'll call this. Because for this root is what I'm calling left and this root is what I'm calling right, right? So now next I'll call root.right. That is nothing but 5. I'm checking if 5 is equal to 4, 1, 2. No, it's not. So my left has returned false and my right has returned, my left has returned true and my right has returned false. Okay. I hope you understood. Let me explain it again. So for 3, wait, let me erase this. Okay. For 3, what did I do? I checked if this tree is the same. For 3, wait, let me actually tail it. For this tree, what did I do? I checked if 3 is the same as this, right? No, it's not. It's not the same. So what did I do? I moved towards the left. What did I do? I called 3.left, right? So what is 3.left? This entire tree is 3.left. Okay. I sent this entire tree and I checked with this tree, right? Now this value has returned true. So the left recursive call has returned true. Now I'll come back. Now the right recursive call will happen, right? The right recursive call will happen. So what will it do? It'll call this tree and this particular tree. Okay. So these two trees, when you compare, this will return false, right? So what has my function returned? My left root.left has returned. So my yeah, So my root dot left has returned me true, whereas my root dot right has returned me false. Now what should I return in this case? Should I return false because either of one of them is false? No, right. I have to return true because I have already found the tree on the left side. That is why my root dot left is true. So if either of the sides I find the tree, I have to return true, right? But in this case, what did we see? When both of them are true, only then I return true. But in this case, when either of them is true, I return true. Okay, these two are a most important thing in this particular problem, and we'll use this to solve the question. Okay, so let me code it. So I'll have an helper function, right? Let me call the helper function as public boolean is same, and then this will take 3 node of p, 3 node of q. Okay, now if p equals to null, that is this condition that we saw, I'm basically writing out these conditions that you see. These conditions I'm writing out. Okay, if p equals to null and q equals to null, what I'm going to do is I'm going to return true. Perfect. If p equals to null or q equals to null, I'm going to return false. Sorry, yeah, I'm going to return false. If p dot val not equal to q dot val, I'm going to return false. Now, what did I tell you? If left returns true and right returns true, only then we'll be returning true. So what we can do is same of p dot left comma q dot left. I'm calling the left side, and is same of p dot right comma q dot right. Perfect. Why and? Because only when I get true over here and true over here, I'll return true. Okay. Now, perfect. Now I'll have the is subtree. Okay, is subtree. What were the conditions that we saw? These two are the conditions, right? These two are the conditions. Okay. If my if root equals to null, I can just return false. Okay. Whereas if my subroot equals to null, I'll just return true. Okay. Else, what will I do? I'll check if is same tree of, I'll call the helper function, root comma subroot. What is it? It will return, if it's the same, I'll return true. Right? Now, what will I do? Here, I need to either return left or return right. If either of them is true, I'll return true, or I'll return false. Right? So I'll call is subtree of root dot left. Okay, and then subroot. Why am I not passing subroot dot left? Because you need the entire subroot, right? That's pretty trivial, right? Or is subtree of root dot right comma subroot. So here, what am I doing? Why am I using OR condition? If either of them is true, I'll return true, right? That's exactly what I want. This subtree will in turn call as same, right? So for every subtree of root, this particular is same will be called, and this will run, and this will give me the answer. Okay, if it's true or false. Okay, let me run this. Perfect. Let me submit it. Perfect. Now, what is the time complexity? The time complexity is nothing but it will be, since since I'm passing through both the trees, that is both the trees, right? That is the tree on the left side, that is root, and on the right side, right? So I'm traversing through each node of both the trees, right? So for one node it is for one tree it is n, for another tree also it is n. So your time complexity would ideally be m into n, where m is the size of first tree and n is the size of second tree, right? This will be time complexity. And your space complexity will be O of n because of your stack, right? Ideally you're stacking up O of n times. Okay, I hope you understood the solution, and thank you so much for watching. Thank you.